Okay guys, in today's video we're going to do an introduction to routers. For this project you're going to need to have two Windows PCs or laptops and a cheap router. I'm using a Netgear N300 and anything similar that's got just simple functions, low capabilities to start off with. And these can be used, you can get them, like I said, it doesn't matter if it's a PC or laptop, Windows 10, Windows 11, they all work. So once we get through this whole setup between the three of them here, we'll go over to the actual router configuration and connection to the internet, and finish it off with a connection to the internet source to give both the computers access. So we're going to go through the Netgear in detail in the next video in the setup, and we'll be using Wireshark while we're doing it to see the different functions. But for the initial introduction, I wanted to go into the functionality of it and some of the definitions, and show you a couple of examples. For the Netgear router, I've broken down, I made this drawing to show its basic functions, and some of the most important things that don't occur to you until later on as you work on this stuff is that the routers, they have essentially a built-in switch, and even if you didn't want to connect the devices over to the internet or have anything to do with this side of the world, they can just fill in real quick as just a switch, and that so two devices can talk to each other as if they had a crossover cable between them, multiple. And the neat thing about a router is that it adds the Wi-Fi connection to it, which is just like another virtual port on the switch, and as many Wi-Fi connections is just adding another port, etc. So but anyway, it can do this switch function without any help from any brains or anything, just like we covered in the previous video, without a MAC or a IP address. And then on this side of it, this is when it gets into its smart functions, which is the DHCP, the gateway, DNS, and then the firewall to the internet. So and we'll go into detail on each one of these. I did want to bring up the to start off with, which is your basic plain English, simple definitions of each one of these. And this is what I just got off just asking Google for each one, what's DHCP. So these four items here, the DHCP, DNS, gateway, and firewall, these are critical things to get completely understood before you move on. And it's not just a matter of memorizing what the letters mean for a test, or select one of four for it. I'm not talking about doing any kind of testing whatsoever. I'm talking about actually understanding how it works, so that you can get into more and more complicated things. And I would these are kind of like the basic addition and multiplication in mathematics, in that if you don't get these down completely, they just haunt you forever and ever. So take these, like I said, and get a good understanding of them before you go on further, so that you when we get to the point where we actually see it on Wireshark, you have a pretty good understanding of what you should be looking at. Now back in the router configuration here, we'll also go over some of the firewall things, and about port forwarding, which is essentially a way to get around the firewall for special circumstances, and the things that you need for this side. And I put in here intranet because this doesn't necessarily have to be an internet connection. This is just a connection to another network, and it could be a completely a network just like this, but you just want to keep separated. So I don't want to get confused that a router is a internet provider, because it's not. That comes from a modem or from another device that connects to an internet service provider, but is not a router itself. But we'll get to there. I wanted to go back and kind of quickly refresh on the connections part of this, and to remind people about the IP addresses and how they work with the MAC addresses. Now, in the first network we looked at was the crossover cable, and if you use a crossover cable with auto negotiation, you'll get the full 1 gigabyte per second connection between the two. And this allows these two computers to talk to each other. And in this case, because they are on the same, they have the same network mask and they're on the same domain here, the 172.1.9, they can talk back and forth to each other. And they obviously there's no intelligence in the cable. So when we go to the simple switch, it's the same thing. No intelligence whatsoever, talking back and forth using the device. But they're limited to now just a 100 meg connection because this particular brand Netgear switch, that's as fast as it can go. So they're limited to 100 meg connections on each side. But once again, the switch has no MAC address, no IP address, and it's essentially invisible to the PCs. They can't see it's there. And as far as they know, it's a 100 megabyte crossover cable. Now, the first look at our router here is where it's coming in here, and it's mimicking a switch. But it also has the additional capability of having the virtual Wi-Fi connection. And that speed is can vary depending on the settings of both sides of the Wi-Fi devices and their the signal quality of how good a connection they have. But once again, it's invisible to the two PCs. The Netgear in between is not presenting a MAC address or an IP address. And yes, the Wi-Fi's can be configured for static IP addresses, so you don't have to get assigned an IP address when you connect Wi-Fi. You can change it in the settings just like you do for the Ethernet connection. But this is the router in its mimicking a simple switch. Now let's look at it in its full-blown version, where it actually offers the DHCP gateway and DNS and a connection to the internet. However, I wanted to use this example so that you understood that just because the computers are connected, quote unquote, to the router, and in this case they would be connected, and these two PCs could talk back and forth to each other, that is true, but they couldn't utilize any of these other functions that the router is going to do for them and take them to the internet, because the router is programmed for a different domain in its IP address. So the network subnet mask here would prevent these two PCs from having any communications whatsoever with this device. And even if they did have the right IP address, if this router was set to 172.19, they still wouldn't have any luck because they didn't have that IP address assigned in their default gateway or DNS server, so they'd be out of luck that way as well. So just because you're connected to something doesn't mean you can actually talk to it, and that's a huge fundamental concept to realize. And that even when they send out broadcast messages with all lefts, as soon as the packet is opened up and they see that the origination address is something outside of their subnet mask, they immediately throw it away and they ignore it. They will have nothing to do with it. So normally we get around all this stuff in that if we're going to hard program static IP addresses, we also hard program in the gateway and DNS addresses as well. But the easiest way for any of this is to just use DHCP and let the router do it for you automatically. But there are various reasons why you have to use static IP addresses, especially in the telex world. So it's important for you to understand that you can do this either automatically or manually. Either way, it works either way. So, but once you do get them changed over, and now we have the correct IP address for the default gateway and the DNS servers, now the PCs here will be able to make full use of the router and get access to the internet and everything else that it was supposed to do. So, and this is when they're able to communicate with it. Now, so let's say you're going to send a packet from this PC over to this PC. You're going to ping it. So as soon as you send your ping out, when it comes across over here to the router, it sees that you're trying to ping another device that's on the local network. So it'll automatically switch roles and pretend like it's an invisible crossover cable, and just send the packets over to this other PC. Now, if you say, hey, I want to go to yahoo.com, now when that packet comes across, it's going to immediately see, oh, hey, this packet is going toward the gateway. So now I'm going to pretend I'm on the same port. Now I'm going to pretend that I have a MAC address, and it's going to need to have the accurate MAC address, because when we first connect, it's going to ARP me for that MAC address, because it's going to say, hey, I'm programmed for a gateway of 168.1.1, and it's going to ask as soon as it boots up, hey, or connects, I should say, hey, who has 1.1? Because you're my gateway, and I need to know your MAC address. Because anytime I send you a packet of information, I need to know that MAC before I can send anything to you. So it'll work. It'll have all that stuff worked out, and it does this transformation from, okay, yeah, I'm a legitimate port and I'm a device just like you are, to no, I'm an invisible crossover cable, and it can do it in a split second, back and forth, no problem whatsoever. So just keep in mind that it does that little trick of like, oh, you want my attention, oh, you want me to ignore you, not be in your business. So, okay, well, that's going to conclude the introduction, and on the next video we're going to get into the actual nitty-gritty of how to get into the Netgear router and configure it, and we'll look at all the connections with Wireshark. Okay, hope this helps, and we'll talk to you soon.